Hey there everyone, I wanted to give you a more in-depth overview of my used oil analysis result for my 2019 Ram 2500 with the 6.4 liter Hemi. I know I didn't give you guys a picture of it in the last video, but that's what I hope to fix that issue with this video and really give you a lot better idea of what my results were and how to, if you get this type of analysis done, how to interpret your results also. With the truck, I had 7,600 miles on the oil, and I think it came out to be about 3,500 miles towing. We have a 32-foot camper, probably 7,500 pounds between the camper and all the extra gear and all of us in the truck. Now, most often we take that, we'll go on trips to campgrounds that are maybe, an hour and a half to 3 hours away most of the time. And then once a year we have a long trip. I have family in New York, northern New York, and we'll put between 1,500 and 2,000, maybe even 2,500 miles on the truck in about a 2-week period. So now I just want to get into the report, right? So the first thing is up in the upper right hand corner, they have this scale, and you can see it says 2. So while it's abnormal, it's not anything to be worried about, or it's more of a, this is what's going on, and these are the things that you need to monitor for your next oil sample. So the things that are below in yellow are maybe some of the things that are worth trending and watching over the number of changes, or the number of samples that you do out of the engine and everything. So the first thing is, so I'll read their comments first here. So it says, flag data does not indicate an immediate need for maintenance action. Continue to observe the trend and monitor equipment and fluid conditions. Base number is moderately low. As the base number depletes, the ability to neutralize acids is diminished. Suspect most of the copper may be coming from the lubricant cooler and or EGR cooler as applicable. Iron is at a minor level. Iron sources in engines can be cylinder liners, iron pistons, hardened steel camshafts, crankshafts, gears, hardened rocker arms, valve bridges, alloyed steel cam followers, rollers, etc. Fuel dilution is at a minor level. Boron is slightly low for this lubricant. Boron levels may naturally decline with use, so this is not a cause for concern. Water is at a minor level. Your note was taken into consideration. Oil is suitable for continued use. Resample in 3,500 miles or 65 hours. In my case, it's a vehicle, so it's an engine in a vehicle, so I'm going for the 3,500 mile mark. So my note that I put in there was that, I had my daily commute was 9 miles one way, and when I wasn't doing that, it was pulling a camper. And that just, I felt it was important to put that note in there, just to give them an idea. Obviously, yes, it's a heavy duty truck, but people do different things with them. Not everyone tows with them. Not everyone drives 9 miles one way. I figured that information might be good for them because they've got, a ton of data to look at and really make good determinations on what people should do. So now to get into the meat of this. So iron came back at 93 ppm. So like in the note, and the nice part about these guys is they have, if you go and look at your oil analysis online, and you can actually click on each of the elements in the report, and they give you a short description on where stuff can come from. So for iron, so they put cylinder liners or just cylinder bores in general. Beyond that, rings, gears, crankshaft, camshaft, rods, valve train, oil pump gear, wrist pins, casting line, casting iron. So really, I mean, given that the 6.4 is an entirely iron engine, well, nearly entirely iron, there's a lot of places for the iron to come from. You know, I've seen people with older Hemis that they get lots of, after 100 or 150,000 miles, they have to back flush the heater core in the HVAC system because it's plugged full of swarf, casting sand, and other debris left over from the manufacturing process. So I wouldn't find it hard to believe that there's still some more junk just washing out of the engine. So next on the list was chromium. Chromium, they say comes from rings, liners, exhaust valves, shaft plating, and it's also part of some stainless steel alloys. Nickel is mostly the same thing. It's used for hardened surfaces, so crankshaft, camshaft, any other hardened surface like that. That's where you're going to find that. So next is aluminum, and they had that at 6 ppm. They said pistons, thrust bearings, turbo bearings, which obviously a 6.4 gas engine doesn't normally have a turbo on it. And then they also say that main and rod bearings in Caterpillar engines, which is an interesting concept, but outside the scope of this video. So next up is copper at 178 ppm. And this was probably one of the most surprising results for me from this oil analysis. If you watched my first video, you see what my speculation is on it, and that's much what they're saying. So in the comments, they said the same thing. It's probably out of the lube cooler, and in here. So in their source stuff here, they say main or rod bearings, and then in parentheses it says also look for lead. So yes, if I thought the 178 ppm of copper was coming from the bearings, the lead would have also been flagged, and it's not for this analysis. Brass and bronze bushings, which are also in parentheses again, it says also look for tin and or zinc, and then oil cooler core tubing. So like I said in my first video, I'm kind of under the impression that maybe this truck wasn't worked. It didn't pull a trailer, or it didn't pull a trailer that often, or just not that far. So by me putting the trailer behind it for several thousand miles, really building a lot of heat in the engine, really forcing that, really pushing that for that flow through the oil cooler, probably flushed a lot of copper out. So next is lead, and lead is 0, which is good because that means the copper most likely, or pretty much for sure, did not come out of a bearing. So what they say for here is overlay metal and made in rod bearings, sometimes solder, and then aftermarket additives. So the other bearing indicator is tin, which came back at 1 ppm. They say it out of bearings. It says also look for lead, and then antimony and copper. Bronze bushings, flashing from pistons, solder, and tin lead solder. Next is cadmium, came back at 0. They just say it's an environmental contaminant. Next up is silver, which came back at 0 ppm, and what they say is silver and wrist pin bushings in some EMD engines, which is a diesel engine manufacturer. And then it says solder from cooler core joints. Next up was vanadium. That was 0. They say alloy metal, and then contaminant in marine bunker fuels. So now we're out of the wear metals and into the contaminants. So the first one is silicon, and it came back at 11 ppm. Now silicon is mostly it's just going to be dirt. So if you got someone who maybe they replace their air filter every time they change their oil, you may find that that engine has higher amounts of silicon in it because, you know, an air filter is not meant to filter super efficient when it's brand new. It's really meant to filter super efficient all the way through its life. So you can actually do more harm than good to an engine by changing the air filter sooner than it needs to be, because you're decreasing the efficiency of the filter because it is using all that dirt and debris that is trapped to help filter out more dirt and debris. And that's what they say. They say that silicon comes from silica, which is, or dirt, silicone sealants, and silicates from antifreeze. So one thing you'll notice is when they get in the contaminants section, a lot of this can lead you to understand whether, you know, you've got a leaking head gasket, a leaking cooler, you know, or anywhere that you're getting engine coolant into your oil. Next was sodium at 10 ppm. So in engines, they say it comes from an antifreeze inhibitor, and it's also an additive in unleaded gasoline engine oils, salt water, or spray wash. So if you live near the ocean, you know, you could see a little bit higher sodium values. You know, mine could have just come from the treatment that they put on the roads and driving in the snow in the winter and all the salt and whatever else they put down. So next up is potassium, which came back at 1 ppm. So what they say is it, again, an antifreeze inhibitor, so indicative of a coolant leak inside the engine, solder flux, metal coatings, and potash. So next up is the group of multi-source metals. And the first one is titanium, which I had a ppm of 0. And they're saying it can come from valves, piston pins, bearings, shafts, and also a lubricant additive. Next up is molybdenum, and this is, I would say it's mostly probably out of the oil, but in this case what they're saying is alloy or plating from rings, friction modifier additive in oils, grease contamination, molybdates from some coolants. So if they have a special coolant which may give some sort of, may have some extra additives in it to help for lubricity in the coolant system, that could also be where it's coming from. Next up is antimony, which came back at 0 ppm. They're saying, again, alloy or plating from rings, friction modifier additive in oils, grease contamination, and same thing, molybdates from some coolant. Next up is manganese, which came back at 3 ppm. What they're saying is steel alloy metal in gears in some shafts. So it could be from timing systems, or it could be out of the crank or camshaft. Next is lithium. And what a lot of lithium is used for is greases, and that's what they say. They're saying contact with grease. The final multi-source metal is boron at 38 ppm, and what they're saying is it's a lubricant additive or borates from coolant contamination. So as you've probably noticed, there's a handful of ways for them to tell whether if you're getting coolant in your oil. They can use their historical data based on the oil that you tell them that you put in, and they'll be able to tell you kind of what's there, what should be there, and what shouldn't be there. Next up is the category of additive metals, and it's magnesium at 859 ppm. They're saying lubricant additive and borates from coolant contamination. So a lot of these additive metals are stuff that it's part of the additive package that the manufacturer puts in the oil. And while these should remain fairly steady, they may increase or decrease as time goes on. It's really hard to say what really happens with them. They may form up with other particles, get caught in the oil filter, sink to the bottom, with sludge or other large particles or things like that. Next up is calcium at 1,363 ppm. So what calcium is it's a detergent or dispersant additive. It also says calcium from water contamination and lime dust. This is something to watch over time because it will decrease as it takes, you know, some of this sludge and undesirable things that form in the oil, and it binds to them, and it'll help trap them in either in the oil filter, or it'll make heavier particles, and it'll sink to the bottom of the oil pan and stay there. Next up was barium, which was 0 ppm. So in this case, so it says not commonly found in engine oils, contaminant in drilling applications, and anti-smoke additive in fuels. Next up is phosphorus at 738 ppm. Obviously part of ZDDP additive, anti-wear additive, and it also comes from phosphate ester lubricant. The final additive metal was zinc at 875 ppm. Again, a component of ZDDP, corrosion inhibitor, and galvanized steel from filter canisters. So starting on the next line is the date the oil was sampled, the date they received the sample, the miles or hours that you put on it. Next is the total time or hours on the piece of equipment, whether it's a engine, transmission, it's a car, stationary generator, whatever. Then they ask if you did a change. They ask if anything has been added throughout the change, and then they ask if you changed the filter. Now a lot of this is just going to depend on what oil you're running and kind of what your maintenance schedule looks like. In my case, when I pulled this sample, I did change the filter just because it was my first change, and I think I actually had I can't remember, it might have been an EAO 1551, whatever filter was spec'd, and that was the one that AMSOIL no longer recommends for the 5764 Ram engines, and then also the Chevy motors with the cylinder deactivation due to some issues with the filters clogging prematurely and causing a little bit of heartburn for some customers. So next up is fuel dilution, and which came back at 2.5%, and they measured that with a gas chromatograph. So when the oil's viscosity is lower than 1 centistoke from the known starting viscosity of the oil when new, they'll confirm the fuel dilution by ASTM D7593 GC method. Otherwise, if the viscosity is above the oil's midpoint for the grade, they'll report it as less than 1%. So the next thing is soot, and you do obviously engine oil still turns black, which is soot and other forms of carbon out of just from the combustion process. So they also give you water percentage. Mine came back at 0.1%. They specified the method as hot plate, which really this is a method that anyone can do at home. It's called the crackle test. I'm sure you can look it up, and you'll understand the name from watching a video, I'm sure. The all-important number of viscosity, which came back at 12.4. Maybe I'll try and put on the screen what the weight of a 40 weight oil 0W40 should be. But I think this was on the lower side, but that's how engine oils work. They kind of shear down and thin out a little bit, and then over time their viscosity actually picks back up, and then will actually go thicker than what they're supposed to be. So next is the base number, and that came back at 2.7. So the base number is really what tells you how much additive is still remaining in the oil. And in general, this is what everyone goes by to determine your oil change intervals. Now, you could have a product that still has lots of additive left in it, but the viscosity may be out of range, and it just is what it is. It depends on how the manufacturer designs and engineers their oil, and what base materials they use, what base oils they use. Obviously, a Group 4, Group 5 synthetic will take much longer to shear down and lose viscosity than a Group 3 oil. And on top of that, there are additives that are used that will help combat that, but it is largely due to the base oil used. Next is oxidation. I think this is one of those things that you're just going to kind of have to trend and watch with your samples. So they say it measures the breakdown of a lubricant due to age and operating conditions. It prevents additives from performing properly, promotes the formation of acids, and increases viscosity. So over time, as the oxidation number increases, that's going to be as the additives aren't there to perform their duties anymore, the viscosity is going to increase due to oxidation. And then finally, the last thing is nitration. So nitration indicates excessive blow-by from cylinder walls and/or compression rings. It also indicates the presence of nitric acid, which speeds up oxidation. Too much disparity between oxidation and nitration can point to air-fuel ratio problems. As oxidation or nitration increases, so will total acid number and viscosity, while total base number begins to decrease. Again, just something that naturally occurs with the use of the oil over time. And nitration is primarily a problem in natural gas engines. Well, it could also be an indicator that just the power cylinder itself in general is just degrading over the use of the engine. So there you have it. There's a more detailed description of the oil analysis that I got back, and kind of where they generally see the material come from. I got another sample that I'm going to take in the next couple of months, and I look forward to putting that together with this. I also want to see if I can get a result from pure 040 and use that as comparison in a chart also. And then my plan is to trend some of these over the life of the vehicle, and that way you can understand that as long as you're consistent, your usage is consistent, then you're kind of going to get the same results. And then a few things that are still, then there's still some stuff that's just going to change based on how far you run the oil. Viscosity, base number, oxidation, nitration, and some of the other metal additive contents and other contaminants too. Well, I hope this has been good for you guys, and gets you a little better idea of what I want to do, and the kind of data I want to provide for you guys. I'd appreciate comment, like, subscribe. You have any thoughts, you have any questions, you have any concerns, I'm here for you. I'll answer whenever I can, and if I can't answer the question, I will certainly do the research and get back to you with that. I look forward to making more videos for you guys, and I hope to see you in the next video.